Dear student, let us see lecture number 4. Name of the chapter is limit. ચોથા લેક્ચરમાં આપણે મળીએ છીએ. ચેપ્ટરનું નામ છે લક્ષ. In last lecture we already discussed this pattern. Whenever square root of something plus or minus some function, square root of some function plus or minus some function either given in numerator or in denominator quantity, then rationalize. જો અંશમાં આ પ્રકારે આપેલું હોય એટલે કે વર્ગમૂળમાં કોઈ વિધેય પ્લસ ઓર માઇનસ કોઈ વિધેય આપેલું હોય, ક્યાં કે અંશ અથવા તો છેદમાં, તો આપણે કરણી કરવી એ જાણીએ છીએ આપણે. વી નો ધેટ હાઉ ટુ ટેક એ રેશનલાઇઝેશન, બરાબર. બટ whenever square root of plus or minus square root of some function are given to us, square root of some function plus or minus square root of function are given either in numerator or in denominator quantity, at that time also we have to rationalize. આ પ્રકારનું આપેલું હોય ત્યારે પણ આપણે શું કરવાની હોય છે? કરણી કરવાની હોય છે. You can see that for this sum, numerator as well as denominator quantity of this form. Clear? Here you can see that, here also in that way, that is given to us. So in both this sum, either for this one or this one, we have to rationalize. Here we have to rationalize numerator as well as denominator quantity. Here I have to rationalize only denominator quantity, and I would like to leave this sum for you. Now let us solve this one. Now see, as far as limit is concerned, there is no need to write each and every steps. In last two lectures already seen that how to write step by step. But for multiple choice questions, we have to move fast. How? See here. If we rationalize numerator, likewise, 2x plus a minus under root 3x is given to us. So multiplied and divided by the conjugate factor, 2x plus a plus root 3x over under root 2x plus a plus root 3x. Yes, in this way we can rationalize it. So here let us see, direct step is there. See, that is equal to, can I write limit x tends to a root 2x plus a minus root 3x over under root x plus 8a minus 3 root x into, let us see, rationalize numerator. That means 2x plus a plus root 3x over 2x plus a plus root 3x. Same time, rationalize denominator quantity also. This one, we multiplied and divided by conjugate factor, x plus 8a plus root 3x over under root x plus 8a plus 3 root x. Clear? Now see here. See, these two factors, what we get? A minus b, a plus b. So a square minus b square, yes or no? Yes. That is equal to limit x tends to a, 2x plus a minus 3x. Yes? Yeah. For denominator quantity, see here, denominator quantity, product of this factor with product of this one. Once again, a minus b, a plus b. That comes out a square minus b square, that is x plus 8a minus 9x. Clear? Now remaining two factors, which one remaining there? This factor as well as this factor are remaining. Put as it is, under root x plus 8a plus 3 root x over in denominator quantity 2x plus a plus root 3x. Clear? On simplification, what we get here? 2x plus a minus 3x, that is minus x plus a. And if I take minus sign common, so what we get? Minus of x minus a. That is equal to limit x tends to a minus of x minus a. And denominator quantity x plus 8a minus 9x. So what you get? Minus plus 8a minus 8x. So if I take minus 8 common, then once again x minus a. So 8a minus 8x. If I take minus 8 common, what you get? X minus a. Here what we get? A minus x, sorry. That is of course one and same thing. Into remaining factors are under root x plus 8a plus 3 root x. Denominator quantity as it is under root 2x plus a plus root 3a. Yes or no? Yeah. Now see here, that is equal to 1 by 8 common. This minus minus comes out positive. This minus 1 over this minus and get cancelled. So 1 by 8 is there. This one. So take it outside. That is equal to limit x tends to a, x minus a cancel. So under root x plus 8a plus 3 root x over under root 2x plus a plus root 3x. Yes or no? Yes. Now replace this limit. 1 by 8 is it is, x tends to a, put here, a plus 8a, 9a, that is 3 root a, plus x tends to a, put here, 3 root a over 2x plus a, x is equal to a, root 3a, here also root 3a, under root 3a plus under root 3a, that is equal to 1 by 8, 6 root a over 2 root 3 root a. Root a cancel, 3 is there, root 3 is cancel. What we get? Root 3 by 8 is the answer of this question. Similarly, I would like to leave for you. Now able to do it, these things. Next page. See here, very interesting, important sum. ખૂબ જ અગત્યનો sum છે મિત્રો. I would like to leave this sum for you. Let us recall that very important formula. Limit variable tends to constant, variable raised to n minus constant raised to n over variable minus constant. That is equal to n times constant raised to n minus 1. That we know. Now see here, in last lecture, that thing is also discussed. In a given sum, only variable raised to n is given to us. Rest of part, all this thing we have to arrange. And then we can apply this form. Now see here, observe for this sum, for a given sum. What is variable raised to n? Now see, that is equal to limit x tends to 2. See here, variable 3x plus 2 raised to n, 1 by 3 is given. Variable raised to n. Here also, x plus 30 raised to 1 by 5, x plus 30 raised to 1 by 5. Now see, variable raised to n is given, so first of all arrange constant raised to n. Now take this limit here. If I take x is equal to 2 here, 3 2 is 6 plus 2 8, 8 raised to 1 by 3. In place of 2, In place of this 2, can I write 8 raised to 1 by 3? Yes. On same line, if I take x is equal to 2 here, 30 plus 2, 32. Can I write this 2 as a 32 raised to 1 by 5? Yes. 2 raised to 5 raised to 1 by 5. Ultimately comes out 2. Now you can see that this pattern is arranged. See, which one is given to us? Only variable raised to n is given to us. First of all, arrange constant raised to n. Then arrange in denominator quantity variable minus constant. Clear? We have to arrange in numerator as well as in denominator quantity for this sum. Now see here, next step. Limit x tends to 2, all of you please see here, variable raised to n minus constant raised to n, over we need variable minus constant, is not there, so multiplied and divided by variable minus constant. This one is for numerator. Now let us say for denominator quantity, x plus 30 raised to 1 by 5, that is variable raised to n minus constant raised to n. Over what we need? Variable minus constant. So multiplied and divide by variable minus constant. Now, of course, is arrange every terms. Now we have to see variable raised to n minus constant raised to n over variable minus constant is there. Next we need to arrange variable tends to constant. That thing we need to arrange here. Let us arrange it. Before that thing, please see here. Simplify this one. What you get? 3x minus 6. If I take 3 common, what you get? X minus 2. What is simplification of this one? X minus 2 only. Clear? So in next step, write one more step. This one is, there is no need to write it, but this for only for understanding. 3x plus 2 raised to 1 by 3 minus 8 raised to 1 by 3 over 3x plus 2 minus 8 in denominator quantity x plus 30 raised to 1 by 5 minus 32 raised to 1 by 5 over x plus 30 minus 32. Here what you get? Okay, 3 of x minus 2 and denominator quantity we get only x minus 2. Clear? Now, see here, x minus 2 get cancelled. X minus 2 get cancelled. We get 3 here. So take it outside. 3 in numerator. Limit variable. What is variable in our case? 3x plus 2 raised to 1 by 3 minus 8 raised to 1 by 3 over 3x plus 2 minus 8. And here 3x plus 2 tends to 8. Put the reason. X tends to 2. So 3x plus 2 tends to 8. Why? If we take x is equal to 2 here, 3 2s are 6 plus 2 and that is equal to 8, of course. So what is the reason? X tends to 2 implies 3x plus 2 tends to 8. In denominator quantity what we need to arrange? X plus 30 raised to 1 by 5 minus 32 raised to 1 by 5 over x plus 30 minus 32. Here also x plus 30 tends to 32 because this x tends to 2 implies this one as well as x plus 30 tends to 32. Yes. See, now it is of that form. Variable raised to n minus constant raised to n over variable minus constant and variable tends to constant. See, both this form numerator as well as denominator quantity is of this form. So now apply that form, clear? So that is equal to 3 as it is, 1 by 3, 8 raised to 1 by 3 minus 1 in denominator quantity, 1 by 5, 32 raised to 1 by 5 minus 1, yes. And that is equal to this 3 get cancelled, 5 goes in numerator, 5. Can I write 8 is a 2 cube raised to minus 2 by 3? Yes, we can write it. Here 5 goes in numerator, 2 raised to 5 raised to minus 4 by 5. So that is equal to 5, 2 raised to minus 2 over 2 raised to minus 4. That comes out 5 into 2 raised to 2. That is 5 4s are 20. This is the answer of this question. Now, all of you are able to solve this question. So I am leaving that one for you. Now see here, once again one more typical sum. See, we already discussed whenever either numerator or denominator quantity are of this form, then we have to rationalize. But whenever fourth root of some function minus square root of some function is given to us, then rationalize 2 times. જ્યારે અંશમાં આ સ્વરૂપ હોય, fourth root અને વર્ગમૂળ હોય, then તો શું કરશું? તો કે 2 વખત કરણી લેવી. Clear? Yeah. So this is the typical example. So rationalize this one 2 times, this form. Now see here, that is equal to, now I am writing direct step. Please see here. Can I write x raised to 4 plus 16 minus x square plus 1 upon x square into fourth root of x raised to 4 plus 16 plus under root of x square plus 4? ખબર પડી ને? If not this one is get clear to all of you, then please see here. See, fourth root minus square root is given to us. So multiplied by fourth root plus square root. This is the rationalization, fourth root plus square root. Now here see, a minus b. See, a minus b, a plus b. So fourth root some function no square minus square root of some function no square over fourth root of some function plus square root of some function. Clear? Clear? Now that comes out, square of fourth root is comes out square root of some function, and square of root some function, that is only function, over fourth root of some function plus square root of third function. See, this one is written here, see, directly. Clear? Now rationalize numerator also directly. What we get? Please see here. Rationalize numerator. Limit x tends to 0, x raised to 4 plus 16 minus x square plus 1 whole square. Denominator quantity as it is, x raised to 4 plus 16 plus square root of x square plus 4 into, what we get? Under root of x raised to 4 plus 16 plus x square plus 4. Sorry, huh? X square plus 4. Yes or no? Yes. See, that is equal to limit x tends to 0. Now please see here. X raised to 4 plus 16 minus x raised to 4 plus 8x square plus 16. Yes or no? Now x raised to 4, x raised to 4 get cancelled, 16 get cancelled. What we get? Minus 8x square. So minus 8x square over denominator quantity as it is. Denominator quantity as it is. Now let us write it. X square, fourth root of x raised to 4 plus 16 plus square root of x square plus 4. Second one also as it is, x raised to 4 plus 16 plus x square plus 4. Clear? Now this, you can see that this x square get cancelled. What we get? That is equal to limit x tends to 0 minus 8 over this quantity here. So that is equal to minus 8 over, put the limit, x tends to 0 here, 0. So fourth root of 16 plus square root of 4 into second bracket square root of 16. Here we are putting x is equal to 0. Here also put x is equal to 0 plus 4. So that is equal to minus 8 upon 2 plus 2. Yes or no? Here we get 4 plus 4. 8 get cancelled. Minus 1 by 4 is the answer. Now all of you please see here. See, once again important pattern. See, here we already taken one sum. Here, this part is given in numerator as well as in denominator quantity. Variable raised to n is given in numerator and denominator quantity. While in this case, it is given as a difference. So what we have to do? Same line. On same line we have to move. See, this is variable raised to n, this is also variable raised to n. Here we have to arrange it. How? Please see here. Limit x tends to 2, 4x plus 1 raised to 1 by 4. Now 4 to the 8 plus 1. Yes, that is 9. So minus 9 raised to 1 by 4 minus sign 3x plus 3 raised to 1 by 4. Here we are subtracting 9 raised to 1 by 4. So add 9 raised to 1 by 4. Denominator quantity as it is, x cube minus 8. In next step, what we have to arrange? Limit x tends to 2. 4x plus 1 is our variable raised to n minus constant raised to n. So multiplied and divide by variable minus constant. So here also we have to multiply it by 4x plus 1 minus 9. If I take minus sign common here, what you get? Minus sign. 3x plus 3 raised to 1 by 4 minus 9 raised to 1 by 4. So we need to multiply and divide by this one. 3x plus 3 minus 9. Of course, denominator quantity is x cube minus 8. So can I write here 2 cube? So we need to multiply it by x minus 2. Here also x minus 2. Now all terms are arranged in that form. Variable raised to n minus constant raised to n over variable minus constant. Here also variable raised to n, constant raised to n over variable minus constant. Now what is simplification? 4x minus 8. Here 3x minus 6. 4x minus 8, here we get it. Here we get 3x minus 6. If I take 3 common, then x minus 2. 4 common, then x minus 2. Now here x minus 2 factor, here also x minus 2 factor, and denominator quantity also x minus 2 factor. Cancel it. So write 4 times limit 4x plus 1 raised to 1 by 4 minus 9 raised to 1 by 4 over 4x plus 1 minus 9 and 4x plus 1 tends to 9 minus limit 3 is there, sorry, 3 is outside, 3x plus 3 tends to 9. 3x plus 3 raised to 1 by 4 minus 9 raised to 1 by 4 over 3x plus 3 minus 9. Of course, now in denominator quantity, limit x tends to 2, x cube minus 2 cube over x minus 2. Agree with me? Yes. Now let us apply that form, standard form. That is equal to, for as it is, 1 by 4, 9 raised to 1 by 4 minus 1. Of course. Minus 3, 1 by 4, 9 raised to 1 by 4 minus 1. Over denominator quantity, here 3, 2 raised to 3 minus 1. 1 by 4, 3 square raised to minus 3 by 4. Yes or no? That is taken common. Into 4 minus 3. Into denominator quantity 3 into 4. Clear? So 1 by 4 into 3 raised to, see, 9 raised to 1 by 4. That is minus 3 by 2 over 12. So 1 by 48, 3 raised to 3 by 2. 1 by 48 into 3 root 3. 8 3 ja 24, 2 carry, 4 3 ja 12 plus 2. 14 root 3, 1 upon 144 root 3. This is the answer. Clear? Very good. Now once again let us see most important sum. That is important for AIEEE, means G. Now see, alpha and beta are two distinct roots of this equation. जो अल्फा ने बीटा ए समीकरण एक्स स्क्वायर प्लस बी एक्स प्लस सी इक्वल टू 0 ना बे भिन्न बीजो होय तो आ लक्ष्य मेळवવાનું છે. Now let us see for limiting quadratic form. 1 minute, let us see for quadratic form. See, we know that in lower standard we already known that if alpha and beta are roots of this equation, ax square plus bx plus c is equal to 0, then sum of two roots is equal to minus b by a and product of two root is equal to c by a. Here it is given quadratic equation. It remains quadratic equation only when leading coefficient is not equal to 0. આ સમીકરણ દ્વિઘાત સમીકરણ તો જ રહે જો અગ્ર સહગુણક એ કેવો હોય શૂન્યતર not equal to 0. So we can write this thing. Clear? Now see here. Can I write ax square plus bx plus c equal to 0 as a x square plus b by a into x plus c by a is equal to 0? Yes. So a of this one, sorry, a of this one. Can I write a of x square minus b by a into x plus c by a equal to 0? Yes. So that is equal to a into, can I write here x square minus alpha plus beta into x plus alpha beta is equal to 0? Yes. That is equal to, can I write a of, simplify it, x square minus alpha x minus beta x plus alpha beta. Now take x common from this one, take beta common from this one. If I take x common, then x minus alpha. If I take beta common, then x minus alpha. That is x minus alpha into x minus beta into a. So ax square, if alpha and beta are roots, then ax square plus bx plus c can be written as a of x minus alpha x minus beta. Clear? So use this concept here. That concept are used to solve this one. Now see, here alpha and beta are distinct roots of this equation, ax square plus bx plus c is equal to 0. So we can write ax square plus bx plus c is equal to a of x minus alpha into x minus beta. Clear? Now use this concept here for this one. Now we can start this limit. See here. And therefore limit x tends to alpha 1 minus cos, 1 minute. In next page we are going to discuss this standard form. Standard form is limit theta tends to 0 sin theta by theta is equal to 1 is a standard form of limit. અત્યારે આટલું યાદ રાખી લો. આ સમયનો here I am going to use this form. Of course is a standard form of limit. Same way one more standard form is also there. Limit theta tends to 0 tan theta upon theta is equal to 1. Oh, yes. Now see, in lower standard you already studied in sine Snell rule. In that case you are taking sin theta is nearly equal to theta. Yes or no? Yes. See, sin theta over theta is nearly equal to 1. Nearly equal to means tends to 1. Whenever theta tends to 0, sin theta over theta is equal to 1. So according to this science rules, Snell rules, we can also see this standard form is equal to 1. And for this standard form, limit theta tends to 0, can I write here sin theta over theta into 1 over cos theta? Yes, because tan theta is equal to sin theta upon cos theta. This limit is 1 and theta tends to 0, cos 0 is also 1, 1 by 1 that comes out 1. Clear? So using these two standard forms, we are going to solve this one. 1 minute. How we are going to keep in mind? Let us write here also. Limit sine of some angle over some angle tends to 0, that is 1. Similarly, limit some angle tends to 0, tan some angle over some angle is also 1. Clear? Later on we are going to see this one also. Limit some variable tends to 0, exponential function e raised to minus 1, e raised to something minus 1 over something, that is also 1. These three standard forms of limits are there. Here I am going to use this one. Now one more thing. Suppose we wish to find limit some angle tends to 0, sine square some angle over some angle square. So can I write that is equal to sine of some angle over some angle, sine of some angle over some angle, and give limit here also and here also. That is 1 into 1. So this one comes out 1. Of course, with any power, that comes out to 1. Sine some angle tends to 0, sine raised to some power of some function in denominator quantity, that function raised to n, that is also 1. Is a repeated application of the standard forms. So I would like to see this type, this formula is used to here. I would like to use this standard form here. And one more thing. See, let us see. limit x tends to 0, sine 2x upon x. What is standard form? Sine some function over some function tends to 0. In our case, here some function is 2x, so here we need 2x, so multiplied and divide by 2. 2 taken common, sine 2x upon 2x and limit 2x tends to 0, because x tends to 0 implies 2x tends to 0 also. So that comes out 2 into 1, that is 2. Yes, 1 mean. Now let us see one more sum. Limit x tends to 0, 1 minus cos x over x square. 1 minus cos x over x square. Now in case of trigonometric form, whenever 1 minus cos or 1 plus cos of some function is given to us, at that time rationalize it or use the formula. See, cos 2x is equal to 2 cos square x minus 1, 1 minus 2 sin square x is also there. So I am using this form because we have a standard form in terms of sine. Sine over some function is equal to 1. Limit tends to, that function tends to 0. So use this standard form for cos 2x. So 2 sin square x is equal to 1 minus cos 2x. So 1 minus cos 2x comes out 2 sin square x. So observe here. Here angle is 2x and that comes half of that angle. So keep one thing in mind, 1 minus cos some angle, that is equal to 2 sin square that angle by 2. Half of this angle is here. So use this form, and for 1 plus cos some function, 2 cos square some angle by 2. If we use this standard form, then clear. So to solve the sum based on trigonometric function, problem of limit on trigonometric function, please learn all standard forms of trigo. And then only you are able to understand this type of questions. Now let us see. See, limit x tends to 0, 1 minus cos x over x square. That is equal to limit x tends to 0, 2 sin square x by 2 over x square is there. What we need? Sin square some function, some angle is given to us. In denominator quantity we need that angle square, and limit that angle tends to 0, that comes out to 1. So sin square some angle is given to us, we need some angle square. So here we need x square by 4, so multiplied and divided by 4. Now 2 by 4 is there, so if I take it outside, that is 1 by 2. Limit sin square x by 2 over x by 2 whole square, and x by 2 tends to 0. So that comes out 1 by 2 of 1 using this one. So that is the answer, 1 by 2. Clear? So in this way we can solve trigonometric forms also. But right now I would like to complete this sum. Now see here. Here, all of you please see here. In place of ax square plus bx plus c, can I write this one? Yes. A into x minus alpha x minus beta over x square. Now use that form. Limit x tends to alpha. Which one? So okay, 1 minus cos some angle or some function, that is equal to 2 sin square that angle by 2. So what do we get here? 2 into sine square a of x minus alpha x minus beta over x square. Now see here, what we need? Sine square of some function, we need some, in denominator quantity we need some function square. Now here here x minus alpha square is there, x minus alpha square. Here x minus alpha square is there. A square is not there, so multiplied and divided by it. X minus beta is not there, so multiplied and divide it. So write here a square into x minus beta square. Now you can see that, see, sine square some angle over some angle square, that comes out 1. Now here a square is there, here 2 is there, so take it outside. So that is equal to 2a square, limit x tends to 1 minute, that is equal to 2a square outside, limit sine square some angle or some function over some function square. Clear? And that some angle is tends to 0, of course. Why? X tends to alpha, so definitely x minus alpha tends to 0. So product of a into x minus beta is also tends to 0. So that comes out 0. But remaining terms are there, x minus beta square. So give limit to that term also. Limit x tends to alpha x minus beta square. So that is equal to 2a square alpha minus beta whole square. This is the answer of this question. Now see here. Let us see some based on that form. Limit x tends to 0. Sine 5x upon sine 3x. Let us solve this one. See, now I am going to solve directly. See, sine 5x over 5x into 5x over sine 3x over 3x into 3x. X's get cancelled. 5 by 3 outside. What we get? Sine 5x over 5x, sine 3x over 3x, this one is 1, this one is 1, so ultimately comes out 5 by 3. See, we can calculate this sum in this way for multiple choice question. As far as board is concerned, we have to write step by step, like as previous sum. See, here every step by step is written. Clear? This one is the for board exam, but for multiple choice question, in this way we can solve it. Now let us see here. Limit x tends to 0, sine 3x plus sine 5x over tan 3x plus tan x. We have a formula in terms of sine and tan. What is formula of sine? Limit theta tends to 0 or limit some angle tends to 0. Sine some angle over some angle is equal to 1. Same way other standard form. Limit some angle tends to 0. Tan of some angle over some angle, that is equal to also 1. Now see, one question arising in your mind. See, of course this one is just hint is taken from Snell rule. But mathematically also we can prove it, this result, but right now we are not going to prove these two results. Clear? Later on I am going to prove this one. Same way also I am going to prove this thing. But right now accept this one as a two standard forms. Clear? Yes. Now see, How to solve directly? So okay, sine 3x over 3x into 3x, sine 5x over 5x into 5x over tan 3x over 3x into 3x plus tan x over x into x. Say this x, and this x, and this is directly taken common and cancel it. So 3 into 1, because this comes out 1. So this comes out 1 plus 5, this 5 into this comes out 1. In denominator quantity, this comes out 1. So 3 into 1 plus this comes out 1, 1. 5 plus 3, 8 by 4. And that is 2. This is the answer. In this way, we can solve for multiple choice questions. Clear? So, I would like to see this type of sum for you. One of them. Here. Limit x tends to 0, tan x degree over x. See, we know that in trigonometry form, degree measured to radian measure, pi x over 180. This converted into radian measure. One thing, what mean by radian measure? Radian measure is nothing but it is in terms of real numbers. એટલે કે આ અંશ માપ છે એને રેડિયન માપમાં ફેરવીએ તો રેડિયન માપ શું આવે? એ કોઈક વાસ્તવિક સંખ્યા આવે. તો આપણે લિમિટ મેળવીએ છીએ એમાં વિધેય ક્યાંથી લીધું હતું? R2x or R2R. તો જેનો ડોમેન, જેનો પ્રદેશ સેટ ઓફ રિયલ નંબર હોય is known as real function. That means in our syllabus or in our 11th and 12th science, we have to see the limit of a real function, differentiation of a real function, integration of a real function. So we need to convert it. So convert it into radian form. Limit x tends to 0, tan pi x over 180 over what we need? Pi x over 180. So multiplied and divide by it. Now that is equal to pi over 180 is taken common. Limit tan pi x over 180 in denominator quantity pi x over 180 and pi x over 180 tends to 0, because x tends to 0 implies multiple of x is also tends to 0. So that comes out pi by 180 into 1. Of course, we can write that is equal to 1 degree also. So in next lecture, we are going to see in detail this type of sums. Right now we are stopping here.